Hello friends, I am Vikas Desale. Today we are going to see about HBase database. So let's start with HBase database. Outlines: Introduction, Working, Differentiation with HDFS and RDBMS, Features, Advantages, Disadvantages, Applications, Conclusion and References. Introduction. So HBase is a distributed column oriented database built on top of the Hadoop file system. It is an open source project and is horizontally scalable. HBase is a data model that is similar to Google's Big Table, designed to provide a quick random access to hug amount of structured data. It leverages the fault tolerance provided by the Hadoop file system. So basically HBase is a column oriented database and we can scale it horizontally. It is in Hadoop file system. It is very useful. So it is a part of Hadoop ecosystem also, and once one can store the data in HDFS either directly or through HBase. HDFS is a Hadoop distributed file system where you can store data through a HBase or directly to the Hadoop system through HDFS file system. So data consumer reads accesses the data in HDFS randomly using HBase. HBase site on the top of Hadoop file system and provides read and write access. Next is working. In HBase, tables are split into regions and served by the region server. Regions are vertically divided by column families into stores. Stores are saved as a file in HDFS. There is in diagram HBase architecture where client in between zookeeper used to coordinate in master and region servers, and Hadoop files HBase is on the top of the Hadoop distributed file system. Nextly, Hadoop has three major components: client libraries, a master server and a region server. Master server assigns regions to the region server and takes the help of the Apache Zookeeper for this task. Zookeeper is a framework in a Hadoop file system which is used to coordinate the processes between processes and other programs in Hadoop file system. Handles load balancing of the regions across region servers. It unloads the busy servers and shifts the regions to less occupied servers. Maintains the state of the cluster by negotiating load balancing. Is responsible for schema changes and other metadata operations such as creation of tables and column families. These are the working principles of master server, or you can say the work culture of master server. Nextly is region server. Region are the nothing but tables that are split and spread across the region servers. The working of region server is to communicate with the client and handle data related operations, handle read and write requests for all the regions under it, decide the size of the regions by the following the region size threshold, which is by default I think 4. Next is HBase shell. HBase contains a shell using which you can communicate with HBase. HBase uses the Hadoop file system to store its data. It will have a master server and region servers. The data storage will be in the form of regions tables. These regions will be split up and stored in region servers. Here in HBase, regions are a table. The master server manages these region servers and all these tasks take place on HDFS. So there are some commands which is used in HBase shell, which is a status, which provide the status of HBase, number of servers and other things about the HBase. Then the version, Version command shows the version of HBase which is we are using. Then the table help provides the help reference to commands. Who am I provides the information about user. Nextly, data definition language which is similar to RDBMS commands that are create, list, disable, is disabled, enable, is enabled, describe, alter, exist, drop all, which all are used in the HBase database for this certain operation. You can see here in description. Nextly, data manipulation language where you can use put to insert the rows, get to fetch rows, delete all, scan to display the table, count the number of rows in table, truncate, and Java client API, which is support the crude create, retrieve, update, delete operations and more through programming under Apache Hadoop Apache Hadoop.hbase.client package. Stable, put, and get are the important classes in this page. Then features of HBase. HBase is linearly scalable. You can linearly scale HBase to any size. It has automatic failure support. It provides consistent read and write. It integrates with Hadoop both as a source and a destination. It has easy Java API for client. It provides data replication across clusters to process data operations parallelly. Then HBase history. HBase is as I said earlier, HBase is designed over the big table paper of Google in November 2006. Then HBase first version is released in October 2008. Then January 2008 0.19 and September 2009 0.20. In May 2010, HBase became the Apache top level project. Nextly, differentiation with HDFS. HDFS is a distributed file system, whereas HBase is a database which is built on the top of HDFS. HDFS does not support a fast individual record lookup, whereas HBase is a column oriented. That's why it provides a fast lookup for larger tables. It provides high latency batch processing, no concept of batch process. It provides low latency across two single rows from billion of records. It provides only sequential access of data in HDFS, whereas HBase internally uses hash table and provide random access to data. And nextly, HBase and RDBMS. HBase is a schema-less, whereas RDBMS is schema-oriented. It is built for wide tables. It is thin, and whereas RDBMS is thin and built for small tables, hard to scale. HBase is horizontally scalable. No transactions are there in HBase, whereas in RDBMS is transactional. It has denormalized data, whereas in RDBMS there is normalized data where we can avoid redundancy and other things which is in the form of normal forms, where in HBase we have semi-structured as well as structured data, whereas in RDBMS we only process structured data. Advantages of HBase. HBase is good but not an RDBMS or HDFS replacement. It is not a replacement for RDBMS or HDFS. It is good. It has good configuration, means good operations. Monitor random and consistent read write access in high volume request. Auto failover and reliability. Auto partitioning and sharding. MapReduce and high-pig integration is there in HBase. Low latency access to data. HBase allows data compression and is ideal for sparse data. Disadvantage: slow improvements in the security for different users to access the data from HBase. HBase doesn't support partial key completely. HBase allows only one default sort per table. It is very difficult to store large size of binary files in HBase. The storage of HBase will limit real-time querying and sorting. Applications of HBase. HBase is used in many companies. Here are some of the application of HBase. In Hadoop, in Adobe, HBase is used. Airbnb uses HBase as a part of its Airstream real-time stream computation framework. Then Facebook uses HBase for its messaging platform. LinkedIn, Netflix, Rocket Fuel also uses a HBase. Conclusion. So HBase, at the end of this seminar, we were able to conclude that the parallel execution of HBase is faster than sequential execution for large amount of data. For smaller amount of data, the preferred way would be to go with a sequential execution and with lesser number of processor. This kind of map reduce would not result in memory constraint as well have no reducers. So HBase is faster. HBase is required for many big data processing, and it is important to learn about HBase. Thank you friends. Please subscribe my channel.